video, I am going to explain very quickly why multicollinearity leads to erratic point estimates even though the t-stats are still valid. So let's say you have a regression equation where we have two explanatory variables, that is x1 and x2. So for example, if the dependent variable is grades or GPA, now notice that IQ and intelligence are more or less the same measures. So in this situation, we are going to have high correlation between the explanatory variables, right? And whenever two explanatory variables are highly collinear, that is when we have the problem of multicollinearity in our data. So we are trying to explain grades in terms of IQ and intelligence, and we already know that IQ and intelligence are highly correlated, right? So what happens is that when we have highly correlated explanatory variables, then that leads to larger standard errors, and that in turn leads to low and insignificant t-values. And because of low and insignificant t-values, we have erratic point estimates. Now remember that just because we have deflated or depressed t-values, that does not mean that the t-tests become invalid. The t-tests in the presence of multicollinearity are still valid, and this is something that students often get confused about and mistakenly conclude that due to multicollinearity the t-tests are no longer valid. So you should not make this mistake. T-tests are still valid, it's just that the point estimates are no longer reliable because they are erratic.